Hey everybody. Um, this is a video about multiplying polynomials by monomials. Okay. I just wanted to go over just an important reminder that this Friday, if you are one of my A-Day kids, you have a test. And this is going to be a test over pretty much everything we've covered. So, distributive property, combining like terms, adding and subtracting polynomials, and multiplying polynomials. Okay, so it's kind of going to be a little bit of everything. On Friday, when you guys take your test, we'll have a little bit of a review before you take your test, and then you'll take your test. So we'll have a little bit of a review day beforehand, but pretty much I would go back over your Classkick notes. Okay, so they'll still be locked, but you should still be able to flip back through things that we've gone through. Okay, I would make sure you've done your Khan Academies, you've done your Ed puzzles, pretty much just things that we've gone over. Okay, if you are my B-Day kids, your test is going to be on Monday. Okay, if you are absent on your test day, please be aware that you are responsible for setting up a time to remake the test, either during your lunch, on your academic assist, or after school. Okay, you have to contact me. I will not be contacting you. Okay, if you don't, you will be given a 0 in your grade book, and that will tank your grade, like guaranteed F in the grade book. Okay, email me to work out a time. If you are in quarantine, please just email me. Okay, all right, so let's go on to multiplying polynomials by a monomial. Okay, so to do this, we kind of have to remember a rule that you guys had last year in 8th grade. Okay, so you learned a bunch of rules when like multiplying and dividing and power rules. But the one that we're focusing on today is what happens when we multiply numbers with powers. Okay, so to multiply a monomial and a polynomial, you simply distribute the monomial to the polynomial. Okay, so sure, sounds super simple when you use big words. So let's look at this rule. Okay, so basically, if you are taking these two things that you are multiplying, okay, and they have a similar variable, okay, so they both have an a, and the variables and the exponents are different, you can add the exponents, okay? So let's look at some examples, okay? So example 1, okay, let's use blue. Okay, so we're going to distribute this x in. So we're going to do x times x. Okay, so when we look at this, we might get stuck and not understand what's going on. We have to understand that even though it's not showing, we have an x to the 1 power, and we have an x to the 1 power plus 4 here. Okay, they're not being shown, but we can imagine that they're there. Okay, so we have the same base, they're both x's, which means we can add these two together. Okay, they have the same base, they're both x's, so we can add these two ones together. 1 plus 1 is 2. So I can say that this is now x squared. And then I can distribute my x to the 4, like we've been doing already this year. And 4 times x is just 4x, which we've already done that this year. We know 4 times x is just 4x. And that is our answer. We cannot combine because they are not the same. Okay? This has a square, this has no square. So our answer is only x squared plus 4x. Let's try another example. Remember, you can pause these videos at any time you need to. So let's look at this example. Again, we can distribute this in because these We got all the same bases. All right, so let's do this. So we can multiply these together. So first thing we're going to do is we're going to multiply their coefficients. Well, we know that 5 times 3 is 15. Now, we got to do our rule. So we got our m's are the same. So we know that because the bases are the same, that we can just add the exponents. So 3, I'm going to take my highlighted rec out. So 3 plus 2 is 5. So m to the 5th power. All right, I'm going to pick a different color so I don't get us all confused. Oops. Let's get rid of this guy. All right, and let's do our next guy. So I have 5 times, well, there's a little hidden 1 right here. It's a negative 1, so it's still going to be negative 5. Okay, and I've got m to the 3rd and m to the, and even though we don't see it, it's a 1 power right here. So remember, our rule is our powers can be added. So I see m to the 3rd, I see m to the 1st, so I can add them. 3 plus 1 is 4. So I have m to the 4th power. Okay? And I'm going to remove this so not to confuse us. And I guess I'll switch to an orange color. My last one that I'm going to multiply is 5 times a negative 7. So that's going to give me a negative 35. And m to the 3rd power times nothing here is still just going to be m to the 3rd power. And this is my final answer. Nothing can be combined because none of these are like terms. M to the 5th is not the same as m to the 4th, which is not the same as m to the 3rd. So this is my final answer. Okay, so notice I kind of went in order. Okay, I multiplied my coefficients, so the number out front. I did that first. Okay, then I looked at the coefficient, then I looked at the exponents, or the powers. Okay, so m to the 3rd, m to the 2nd, okay, and then I added them. All right, so kind of think about that when you are doing those. And yes, of course, we are going to do more examples of these. Okay, it can get kind of complicated. And some of these examples are gonna get kind of messy. All right, so let's try another example. Remember, you can pause these videos at any time you need to and rewind them. So let's do some more. Notice I have your rule up here, okay, and multiply our coefficients, and we can add our exponents. All right, so let's look at this next one. Now, remember, if we don't see an exponent, we can kind of assume there's a little one up here, kind of hiding. Okay, so if I multiply this in, k to the 1st times k to the 1st, our rule is that we're adding the exponents. I don't see any numbers to multiply out front. There's no numbers out here, so I don't have to worry about doing that. So I can just add my exponents. Well, 1 plus 1 is 2. So I have k to the 2nd power And now when I multiply or distribute in to the second number, I still have a negative, so I have a negative 9k. You don't need to the first power. It's not wrong if you put it there, but you don't need it there. And this is your answer. All right? Let's try another one. All right, so let's try this. So we're multiplying it. So 9 times, well, I don't see another number there, so it's going to stay 9. But remember, I got one A and another A. Okay, remember I can pretend there's a little one here and a little one here. So I can add my exponents. 1 plus 1 is 2. So I have A squared. If I distribute the 9A again, 9 times 1 is still a 9, a positive 9. And 1 times this A is still just an A. So my answer to this problem is 9A squared plus 9A. I can't combine any like terms because A squared is not the same as A. All right, let's try another one. Repetition is our friend. Yes, it can be boring, but the more problems you see, the more likely you are to kind of catch on. Okay, patterns kind of help our brain learn. All right, so let's try another one. So first I'm going to multiply 6. There's not another number here, so it's going to stay a negative 6. So remember, there's only one p here. So I'm going to add my exponents. So 1 plus 4 gets me 5. So I've got p to the 5th power. Now I'm going to distribute my negative 6 to my negative 8. Okay, so if I don't know what that is, I can get my calculator out and I can say negative 6 times negative 8. Okay, and that gets me a positive 48. So that means I have to do addition. Plus 48. And I'm going to keep the p there. Because p times, well, there's nothing here, so it's still just going to be a p. And this is my answer. I can't combine any like terms because p to the 5th power is not the same as plain old p. All right, let's try number 4. All right, so distribute in. Do our coefficients first. 3 times negative 2. So in case you don't know, you do 3 times negative 2. Looks like I have a negative 6. Okay, and then we can worry about, then we can worry about adding our exponents. So 5, remember, technically this is a 1. There's only one c here. So 5 plus 1 is 6. So I have c to the 6th power. Distribute my 3c5 to the 5th power. Okay, multiply my numbers first. 3 times negative 5. If I don't know that off the top of my head, I can do 3 times negative 5. Gets me a negative 15. So minus 15. I don't have any variables back here, so I'm just going to keep c to the 5th power, what it was originally over here. I can't combine any like terms, so this is my final answer. All right. All right, we got 2 more. And remember, you can always rewind and look at these. Kind of getting sick of orange, so let's try blue again. All right, so we got a negative 4g squared times 2g plus 7. So let's work on our numbers first. So negative 4 times 2, well, that gets me a negative 8. And now I can focus on my exponents. So 2 plus, technically there's a 1 here, even though it's not there. So 2 plus 1 is 3. So I have g to the 3rd power. And I have to distribute the negative 4g squared to the positive 7. And negative 4 times positive 7 is a negative 28. And g to the 2nd power times there's nothing back here is just g to the 2nd power. These cannot be combined because g to the 3rd is not the same as g to the 2nd. So this is our final answer. The last one on this page. All right, we got more x's. This one's kind of nice because there's no numbers to worry about. So we have x times x squared. Remember, there's technically a little 1 there. So 1 plus 2 gets me 3. So I have x to the 3rd power. X times a negative x, still going to be negative, but remember there's 1 plus another 1, so that's x squared. Ooh, don't want that. X squared. And we have an x times a 3. So it's going to stay positive, and it's still going to be 3 and an x. And this is our answer. Nothing can be combined because nothing has the same exponent. X to the 3rd is different than x squared, which is different than plain old x. All right? Whenever you're looking at exponents, you're adding them together. If you just have a number all by itself, you're kind of just tagging on whatever the variable and exponent is. Okay? So notice we had c to the 5th power. Well, 5 didn't have anything, so we just tagged on c to the 5th power after we did 3 times 5. Okay? 3 didn't have anything, so we just tagged on x to it. 7 didn't have anything, so we just tagged on g to the 2nd. All right? Let's try a little bit more difficult problems. What happens if we have 2 variables? Now, are we going to see these very often, and are you going to see these on your test? You're going to see one of these on your test. Okay? So yes, I need you to know how to do them. Yes, you're going to see them more often in algebra, but we're going to slowly integrate them to you. Okay? But yes, you're going to start seeing them. Okay? Same idea. You're still going to multiply your coefficients first, and then you're going to add your exponents. Okay? So let's look at this. So you have p to the 2nd power and q to the 3rd power. Okay? You can only add p's and p's and q's and q's. Okay? So when we multiply this in, we can only add your p with your p and your q with your q. Okay? So you have p to the 2nd power plus p to your 5th power. Well, 2 plus 5 is 7. So you have p to the 7th power now. Then, when you're multiplying in your second one, you can only do your q's. So your 3rd power of q and your 2nd power of q. Well, that gets you 5. So q to the 5th power. Okay, you can only add your like terms with same bases. Okay, you're never going to do 2 plus 2 because P and Q can't be added together because they are not the same letter. Okay? I'm going to pick a different color. Let's pick red. So now let's do your P with your P. So P squared minus, I'm going to put my minus back. Remember, there's a little 1 right here. So 2 plus 1 is 3. So you got P to the third power. And then you've got your Q. So 3 plus 1 is 4. So Q to the fourth power. That's your answer. You can't add different bases together. P's go with P's, Q's go with Q's. All right. Let's look at number 11. All right. So, number 11, we have 5r squared times s squared times all that stuff that's in your parentheses. All right. So, we have to be able to multiply these in. Okay, so let's do our coefficients first. So those numbers out front of the out front of the variables. So 5 times a negative 2. Well, that gets me a negative 10. All right. So we have our r's that we got to put together. So we have r to the second power, r to the second power. So we're going to add them. So r and 2 plus 2 is 4. Okay, so we added those. Now, you're saying, well, what about the second squared? This thing right here, negative 2r squared, doesn't have a s squared. Okay, well, if it doesn't have it, we're just going to tag it on the end. Boom. Just tag it on the end. You don't have to worry about it. It doesn't have anyone to add to, so you just tag it on the end. Okay, I'm going to change my colors. All right, so let's move on. So again, we're going to do our coefficients first. So 5 times 3, that gets me a positive 15. So I'm going to do plus 15. And then I'm going to do my r squared. So I got 2 r's. Technically, there's a 1r right there. So 2 plus 1 is 3. So r to the third power. Okay, and then I got my s's. So I got 2 here. And technically 1 there. So again, I have 3. So s's cubed. And change my color one more time. I don't know, let's pick green. All right, and the last color that I have left to do is 5 times a negative 4. Well, it's going to get me a negative 20. And it doesn't look like I have any r squares over here. So I'm just going to write r squared. The 4s to the second power doesn't have anything, okay? But I do have an s squared and an s squared. So 2 plus 2 is 4. So s to the fourth power. Okay, and this is our final answer. Nothing can be combined because nothing has like terms. Okay, and be careful because this right here is different than this. R squared is different than r to the fourth. Okay, so those are different. We can't add the negative 10 and the negative 20 together because those endings are not actually the same. So be careful. All right, those are a little bit more tricky. Okay, I would just be careful and say, if you don't see anything that can add, just stick it to the end and then keep going. All right, you won't see these very often. All right, these ones, we're adding an extra step. we're adding in the combining like terms. So we're still multiplying our coefficient, we're still adding our exponents, but now at the end, we're doing some simplifying. So we're going to see if we have any like terms and we're going to add them together like we've done in previous lessons. Okay, so let's look at this. Okay, so we're going to have to distribute first. So -2 times 3, that gets me a -6. All right, and I've got 1x and another 1x, and 1 plus 1 is 2. So I've got x squared. All right, and then I've got a -2 times a -4. And if you aren't sure your rules, -2 times -4, that gets me a +8. So make sure you put +8. And I got to make my x's. X, and there's nothing over here, so I just tag the x on at the back. And then this is just on the end. Nothing's getting multiplied because it's not in the parentheses. So we're just going to bring plus 7x down. Okay, now we're looking for combining like terms. Well, 7x and 8x can go together because they just have one singular x. Now be careful. We're no longer multiplying. We're just combining like terms. So -6x squared is just being brought down. And now we're just adding. Well, 8 plus 7 is 15x. And this is our final answer. Okay? Remember, we only add exponents if they're being multiplied. In this case, they're not being multiplied. These are being added. Okay? I know that's a lot of words. That's a lot of rules. Okay? But you're only adding the exponents if you're currently multiplying them. If they're just a normal combining like terms, you're adding. All right? Let's try another one. A little bit more complicated. Okay? So 5 times a -7 is a -35. Okay? And you've got 1w plus 1w, that's 2. So w squared. And 5 times 3 is a +15. And there's no variable on the back, so I can just bring down the w. My next one, we have to be careful we see this. It is a -2 times w. If you forget to see this negative, you're going to make an error. So -2 times 13 is a -26. There's nothing, no variables, so I can just bring down the w. And a -9 times a -2, well, that's a +18. Two negatives when multiplying get you a positive. Okay? And 1w plus 2 more w's make 3. So that's a cube. Okay, we can now combine like terms, starting with our highest exponent. So w cubed. Well, 18w cubed doesn't have anything to add with. So I'm just going to bring it down. 18w cubed. All right. My next w is w squared. It also doesn't have anything, so negative or subtracting 35w squared. All right, and that leaves me with 15w minus 26, which if we need a calculator, we can get out real fast. 15 minus 26, which leaves me with a -11. -11w. And there, we're done. We have distributed, we've combined like terms. There's nothing more we can do. That is our final answer. Okay, Do I think you're going to see an answer like 16 very often? No, I don't. Okay, but I want you to be aware of them to see that they do exist. Okay, we have 2 more problems in this video. Okay, and they are some geometry problems. You're going to see some geometry problems on your test. You're going to see one on your homework. Okay, so the first one is find the area of a trapezoid. It's been a long day. Of a trapezoid and simplify your expression. Okay, so I put the formula to find the area of a trapezoid. You take half the height times base 1 times base 2. Let me show you what this looks like. Okay, so you have half. Let's pick blue. So you take half of your height, and then you multiply that, your base of your first base plus your base of your second one. Okay, so let's put what we got in there. So we have half times our height. Well, here's our height right here. So that looks like 4x squared times base 1. So that can be this top one. So we have 8x squared plus 3x. Okay. And then we have our second base. So plus this one down here. 2x cubed plus, that says minus. I can read. Minus x. Okay. Which looks kind of crazy. So let's simplify this a little bit. Let's focus on this. All right, let's simplify this a little bit. This just says, what's half of 4? Well, if I have $4 and I give half of it away, I have $2 left. And x squared just comes with it. Remember, it's like a label. It's like if I had 4 cars and I gave half away, I have 2 cars. If I had $4 and I gave half away, I have $2. If I had 4 pieces of gum and I gave half away, I have 2 pieces of gum. This x squared right here, this is just a label, okay? So when you think half of 4x squared, half of it is just 2x squared, okay? And then let's bring all this down. 8x squared plus 3x. Let's see. Before I do that, let's back up a little bit. Is there anything up here in this section that we could make our lives a little simpler and combine like terms? Well, is there anything that can go with 2x cubed? Not that I see. So let's just bring down 2x cubed. Is there anything that can go with 8x squared? Not that I see. So let's just bring it down. All right. Is there anything that can go with 3x? Why, yes. Plain old x. So what's 3 minus this 1x? Well, that's 2 x's. So we kind of just simplified our life a little bit. We can do that. All right, so now let's multiply this through. So 2 times 2, that's 4. And now we're going to add our exponents. Well, 2 plus 3 is 5. So I have x to the 5th power. So now I can do 2 times 8. Well, that's 16. And now I'm going to add, get that to go away. Okay, let's pick a different color. Let's do purple. So I'm going to do 2 plus 2. Well, that's 4. So x to the 4th power. And let's do one more and see if I can make it red. All right. So I have 2 times 2. That's 4 again. And I've got 2 plus 1 over here, which makes 3. So I have x to the third power. Now, not that this makes a whole lot of sense because we don't know what x is, but we know that this is our area of that trapezoid. Okay, 4x to the fifth power plus 16x to the fourth power plus 4x to the third power is our area of that trapezoid. Okay, when it's all simplified. And the last one we're going to do in this video, and I'm sorry this video is so long, so we're going to find the area of the shaded region. Okay, so this region in green. Okay, so we don't want any of the region that's in white. Well, if we don't want something, that sounds like subtraction to me. So it sounds like we want to know what the whole area of the gray would have been, and then we want to subtract out the area of the white. Okay, so pretend that that greenish gray area was a cake, and then somebody took a really mean piece of your cake out, just totally savagely cut out this piece of cake. Okay, so we want to know the area of what's left after they took out this really horribly no good piece of cake out of your cake. Okay, so we want to figure out what's left of your cake. So we're going to subtract. Okay, we're subtracting the bigger area, the area kind of shaded in green, from the smaller area, the one in white. Okay, so how are we going to find area? Well, area is length times width. Okay, so we want to find the area of the big area first, the gray area. So we're going to find 6 times 8x minus 1. So let's set that up first. So we're going to do 6x times 8x minus 1. Okay, because that's the area of the large square. I shouldn't say square, it's a rectangle. And then we're going to subtract it from the smaller one, which happens to be 2x and 5x plus 3. Okay, we're subtracting it. So now let's solve this. Let's pick a different color. I don't know, purple. So 6x times 8. So 6 times 8, that's 48. And remember, we got 1x and 1x. So we add when we're multiplying variables together. So that's 2x's. And then I got 6 times a negative 1. So that's just a negative 6. And there's no variables here, so I'm just going to keep x. Now, here's where you got to be careful. This is a negative 2x. We got to make sure we take the negative with us. So negative 2 times 5 is a negative 10. And 1x plus another x is 2x's, so x squared. And negative 2 plus 3 is a negative 6. And there's no variable here, so we're just going to tag on our x. So now let's combine like terms. Let's do oranges. Okay, biggest exponent goes first. That happens to be my x squared. So I got 48x squared minus 10x squared. Well, 48 minus 10 is 38x squared. And the next one I can subtract is minus 6 minus 6. Now some of you might say that's 0, and I would caution you to be careful. Minus 6 is negative 12. Negative 12x. And here is your answer. This is your area of what's left. Okay? Sorry, I threw my pen. That's your area of what's left. Okay? So we kind of have to be careful. Those are a little bit more complicated. Okay, it requires you to know what the formulas are and how to input your information. Okay, you might have to watch those videos more than one time to kind of understand what's going on. So here's your homework. I greatly simplified what your homework was. Yes, there's an ed puzzle. Yes, you have a few Khan Academies you need to look at. But I simplified your homework a lot. Okay? So you have 1 through 4 and 7 and 8. Okay? There's, as you can see on here, there is just multiplying your coefficient and adding your exponents. Okay? These are very similar to the first couple that we did. Okay? So think like slides 3. Okay, 1 through 4, 7, and 8 are very similar to slide 3. Okay, 10, 11, 12, and 16 and 17. These are very similar to 4 and 5 on slides. Okay, oops. And then this one down here, okay, another one of these shading problems. This one is very similar to slide 6, which we just did. Honestly, it's easier than the one that we did on slide 6. Okay, it has easier numbers to work with. Okay, easier numbers. So I would look at the one we just did on slide 6 together and kind of reproduce it for what we did. If you have any other questions, please email me. Please watch this video more than one time to kind of see what's going on. But that is what we are doing.